Good morning. So tomorrow is your first test. It's worth 10%. I'm going to send it in the morning and you'll have 6 hours to complete it. You shouldn't take 6 hours to complete it, but that's how much time you have, okay? I thought that I would work with the test 1 prep questions. There's some that I didn't give you the answer. Well, I mean, I gave you the answer, but not the worked out solution, so that we would have something, that you would have something to struggle with, okay? Because you need some exercise. How do you build muscle, right? You challenge them. So I challenge you to try those exercises, and I know some of you did, but you just didn't feel comfortable. Some people contacted me, and I did some office hours online. If you've had a chance to see those, great. If you have not, you can have a look in the future. If you want some help from me, I can meet you virtually, or you can send me questions, and if you can't meet with me, I'll just post the answers online. Or anyway, I'll answer your question the best I can if I can't leave it to the class. So I promised I would do some of these, unless some people have specific concerns other than this one. Good morning, everyone. Maybe you can let me know if I can just start here. So the test tomorrow is to be completed individually. You can use any resources other than a human being to assist you, okay? You should be able to complete the test in an hour and a half. Good morning. The test will be, what did I say I was going to do? No, I'm going to send you problems like these kind of problems that you've been practicing. And then you work on them on separate pages and scan them and send them back to me, okay? And I'm going to give the key, the clave, to my grader, my assistant, and the assistant will be grading. I will share the solutions with you so you'll have an idea of what you did wrong and also to check your work. So also for something for you to study from, another document for you to study from. So Connect, I'm going to give you Connect exercises to complete for, I think it's 10% of the class. I have to verify. I'm going to give you Connect exercises to complete after this test. So I really want you to work with these materials I've given you. And then as an expert, you can tackle the Connect problems. Okay, what I want for the test is that even if you take pictures and you scan them, you have to combine them in one document, okay? If you know how to do that. If you don't, find out. You can ask someone for that, okay? You need to send it as one document, not separate pages. It becomes very messy, and then I have to combine them, and I don't have time for that. So you need to send the test as one complete document. So whether you take pictures, you got to combine them. You need to combine the pages as one PDF. Don't send me individual pages. It just wastes my life. Yeah, we'll do it via email. What I'll do then is I'll combine them into a Dropbox folder and share that with the TA, and he'll grade from the folder. And he'll mark up the exercises so you can see where you went wrong. Or you can follow along with his grading. All right, we did some of these problems together already. Where would you like me to start? Any preferences? Also, there are still some people who are missing documents. Please let me know what you're missing. I'm not sure what happened. Everything I sent was through the registrar portal, so that everybody registered in the course is getting the documents. Then I did use something in an email in Outlook, and I responded to it, and I think it didn't include everybody. I'm not sure why. I think they're developing Outlook. It wasn't easy to send emails to groups, but now it's easier for me. Maybe I'm figuring it out as we go along. So yeah, the instruction will be just like the ones here, right? It will be so they're just like these ones up here. So I didn't say here to put your, so I'll have to add a statement to this, something like this, right? Where I say put your timeline and your formula and the answer. It's chapters 1 to 4. Just double checking. So the assignments in Connect are worth 10%, and the chapters are 1, 2, 3, and 4. But really, it's the materials I've given you. For Connect, I'll give you exercises in chapters 1 to 4 to work on after the test. So next week when we meet, we begin the new topic of projection of cash flows and techniques for valuation. Okay, so any comments? Okay, so no comments. Is 1 good? Everybody's good with 1 and 2 and 3? We're going to skip these. 4 and 5 and 6, 7, 8, 9, 10. Okay, somebody asked me about the birthday one because there's no answer. I believe somebody asked me about the birthday problem. Number 4. Oh. Do I not have a solution for that either? I'm just getting organized. Okay, so number 4. All right, so I didn't solve it. You guys don't like that, right? Okay, let's see, number 4. So this is a bond problem. You can take the information on the variables and find the return. Unfortunately, my neighbors are doing construction every day, except for Sunday, I think. And I hope you don't have to hear that too much. There's not much I can do with that sound. I complain. That's all I can do. I think people should be able to do construction in a condominium, but I think between certain hours, and they should let me know when they're going to do it. It's just not, doesn't seem fair. All right. So I want to find the return. So I set this up. Now for a problem like this, on a test situation, you actually have to show me your formula. So to solve this, well, yes, because I want you to, even if I give you a multiple choice question like something like this, you would have to show me your work, right? Yeah, I want to see the work. So remembering that a bond is the present value of an annuity plus, you can't hear me? Oh, you don't hear the banging. That's good. Okay. I have a good microphone. It drowns out that sound, I hope. So, it's 7.2% coupon, so let's convert that right away. That means that the payment is C over 2 times 1,000, right? So C is 0.072 divided by 2 times 1,000. So that's the payment. which is $36. I can move that away, no, and then delete this. I need that space. So that means then that there's going to be an annuity with $36 and the rate that I'm trying to find as a yield to maturity. And so I write this like this for 22 years or 44 semi-annual periods. So that's 44. And then you get the face value of the bond at the end. Oh, and I also seem to know that the price, right? I have that information. So I can put that in. So that is what I write, and then I just use my calculator to find I. How to use the calculator? I'll put the calculator notation in a different color. So to put it in the calculator, you enter I'm just reading the questions. You need to write the formula like this and then just put the answer. For a bond type problem, you don't have to write the timeline, correct? Because it's just going to be super long. I want timelines for when you have to show me a pattern and your application of the formula. Here we already know the pattern. An annuity and basic time value of money for the face value of the bond. Did I answer your question, Bonmighty? Try to get that right. So to put this in the calculator, we would write punch. Oh, actually, I can show you the calculator for this. The calculator. So I enter from left to right, I enter 44. Interest rate is what I want, so I don't put anything. I put the price as 1063.66 as a negative because that's what would be spent for a purchase. That's the cash outflow. The payments received by the bondholder would be the $36 as a positive and the 1,000 future value, and then you compute interest. Right, so you would make, so in answer to your question, you would make a timeline. Oh, where am I going? That's weird. You will make a timeline, yeah, when you have something that's a combination of formula. And you have to show me, demonstrate to me how you're applying the formulas and where. So it turns out that I, when you plug everything in, is equal to what we're getting out of the formula when we punch this in is the effective semi-annual rate. So that is this one. Six months compounded semi-annual. These are the same. This is an effective rate. So this is true. But there's some other options here that I have to check. So this is what goes into the formula. However, the yield to maturity is written as a stated rate. The rate per year compounded semi-annually. Let me erase this. So let me write this here. This first one is EPR 1/2. The second one is the equivalent rate, but written as R 1/2, right? Because it says per year, but compounds semi-annual. The semi-annual goes in the subscript here, and that's the notation. The subscript represents the length of the compounding interval. And when we say per year, that is a stated rate when they're different. So how do we get that? We use our formula that we know. You just multiply. You give me the simple interest equivalent. So you multiply that by 2. And when you do that, you get this number. So this is also true. So you have A and B for sure. Then the other ones, you should check them. But obviously these cannot be both true at the same time. It's either B or C, right? Because they're both the same answer. So it's not going to be C. And we just proved that it's not D because it's B. B is the stated semi-annual rate. And E, let's check E. So just go one at a time through them, solve them, do the equivalency, compute the equivalency. And I made a video working with the document with the two formulas you need for interest rate conversions. From the one from converting between nominal and stated and effective, and the other one with converting from effective to effective. So watch that video called Office Hours. Okay, so I have this one is answer B, and this one is answer A. So the last one I have to check, well, I'm going to check, because of the options, I have A and B, so it's either, well, I don't even have to check. If I'm convinced it's A and B, I don't have to check anything else. It should be this answer. This is the best answer. Because it can't be G, because that's just with A, and it can't be H, because that's just with B, and then also E. So I have to assume it's going to be E because I do have an answer. Anyway, by process of elimination, the answer is I, but let's just verify that E works. E is the EAR, the effective annual rate. So far we've gotten the effective semi-annual rate, we've gotten the stated semi-annual rate, but now for E is finding the effective annual rate. The effective annual rate, so converting from an effective to an effective, yeah, you have to show the process. So this one I didn't have to because I just used my calculator. This one I'm showing the process here for the semi-annual stated rate, and now you have to show the process, yes, for EAR. So for the EAR, let's make this bigger so we can fit it in here. Even bigger. What's stopping me? So we need EAR, but we're given, or we have, I'm going to say we have because sometimes I say have and given because this one we actually computed ourselves. And we have the EPR 1/2. We solved for it with the calculator. So let's make the equivalency relationship. 1 year is equal to 2 half years. And that's the thing I solve. And I say this is the same as, so you do have to show me this formula for points. You can't just show me the number. But I don't expect you to write out the number again because when you transcribe, you make errors. So I'm running out of space. Move this over. I'm going to stick it in here. So you should have the value from your calculator. It should still be there. So let's go back to the calculator. I'm going to add 1 squared and minus 1, and that'll be my answer. So that's my result. I can store it in 1, so it's there. Remember, this is in percentages. So I have to divide it by 100 to have a decimal. Then I'm going to add 1 to make a factor and square it, and then minus 1. Is that the answer? Does anyone want me to do that again? So I stored the value, so going back, that was the value of the interest rate. That was EPR 1/2. That's the effective semi-annual rate. So I'm going to store that, store 1, so that's in my calculator, but that's a percentage. So what I have to do is divide it by 100 to make it a decimal. Then I add 1, and then I accumulate it for 2 periods. And then I take off the principal because these amounts are per dollar invested. And so that is the effective annual rate. Okay. So it turns out, I'm going to zoom out. I hope you don't get dizzy with all the zooming in and out, but we used to joke as professors about an infinite chalkboard, and I virtually have one now. an infinite chalkboard. So I found EAR. Okay, they're all equivalent rates. They're obviously not the same number, but granted what they give you, they're equivalent. I can get one from the other. So notice when I write things down, I avoid transcribing these numbers as much as I can. You're going to have to write it in your test. You have to let me know. So, you know, here you would write your answer. And I would like you to circle your answer, your final answer. Makes it easier for the grader. If you can see that. I'm going to erase that and put it, I'm going to zoom in again. Okay, next. So if you didn't understand, you can rewatch the video. What I found is that A, B, and E are the same answer. Just your final answer. Just circle the final answer. If you want to underline those partial answers, that's fine. I mean, if you're going to circle, it's okay, but I'm just stressing that the final answer can be circled so that the grader can just jump to the final answer and look, and then he looks for support of your work. But you can see you're on the right track if he sees your final answer, or if you're very far off track. All right, what's next? So the other one that I don't have a solution for, so I have solutions for all this stuff. The next one with no solution is 10, right? The birthday one. So what do you have for me? What have you managed to do with that problem? When you retire, you would like to have a monthly pension of $8,000. So you know, this is a defined payments kind of pension, so you know what you're going to get. They call it defined contribution. Is defines how much you put in, and I'm trying to think of the lingo. Anyway, so this is predetermines how much you will withdraw. You've just had your 25th birthday, and you intend to contribute monthly to your retirement fund until you are 60. And then the month after, you'll start taking your pension. Your investment advisor has found a guaranteed investment for your fund that will yield 8% per year compounded quarterly for the duration of your pension needs. How much should you contribute each month to your retirement fund, assuming your contributions start 1 month after your 25th birthday? Let me make sure this is... confusing because I say per month for 30 years, but then I say until you are 60. So what did I do here? Oh, I'm just reading. Sorry. I'm just reading on a different page. So let's go to 10. Okay, sorry, I got it now. So I want to be able to withdraw $8,000 per month for 30 years after I retire. All right, just clarifying that's for later, but right now I'm going to deposit for 35 years till I'm 60. I'm going to deposit an amount, and I'm trying to figure out what that amount is. So you have an exercise like this in the initial set of notes I gave you. Like any problem, you have to first, the initial step is to identify the timing of payments. So step one is always to identify the timing of payments. Payments, okay, wait, we've got to be clear. So the contributions are monthly. The withdrawals are monthly as well. Okay, everything's monthly. And it's going to be the same rate that's given as a stated quarterly rate. Throughout all these years. 30 plus 35, for 65 years, you're going to get 8% per year compounded quarterly. So the payments are monthly. We're given our 1/4 of 0.08, and we need, for monthly, we need EPR 112. So let's figure that out. So there's, first of all, whenever I'm given an R, right away convert it to an EPR, because in this form it's useless, right? So what is R? R is the stated rate. It's just the simple interest rate equivalent of the effective quarterly rate. So it was found by taking the effective quarterly rate times 4 to get the stated quarterly rate. This is the stated one for people who are still trying to understand. But this is the effective one. This is the one we use for our formula. So that's the relationship. So I want this. Well, that's the best I can do. I really ultimately want the my endpoint is that I want the monthly rate. But the best I'm going to do is first getting the quarterly rate and then converting. So first I get the effective quarterly rate. You see what I did? Can you see that? So that's just 2. And then this is effective. If it doesn't say effective, so I did a video where I explained this is the rate per month compounded monthly. The clave is realizing that these have to be the same, month and compounded monthly. When they're the same, that's effective. When they're different, it's stated. The stated rate here is the rate per year. Notice if you look in the problem, compounded quarterly. This is different from this. That's how you know it's stated. Okay? So if you have some time, watch the video that I did in office hours to review conversions. Okay, so when they match, it's effective. Or when I tell you it's effective, it's effective. If I don't tell you it's effective, you have to dig, you have to read and be clear what it is. Exactly. Okay, where are we? We have now the quarterly effective rate. Are we finished? No, because I want this. So going from the effective quarterly to the effective monthly, I have to make a statement. The statement is that between EPR 1/4 and EPR 1/12, what is the relationship? Which one is the smaller one? I want to make an equivalency relationship. Which one is smaller? Oh, you can't see. I'm going to move up. So the first step is always identify the timing of the payments and get the rate you need for growth or for compounding interest. Right, so the effective monthly rate is smaller, and if I accumulate, right, because these are effective, I accumulate. I include the interest on interest, so I have to compound in factors. So, what's the relationship? This is smaller, the months. How many months in a quarter? How many months in a quarter? Right, okay, so be clear, it's a quarter. Write it somewhere on your formula sheet to remind yourself, because it's a common error. There's 3 months in a quarter. Mentally, that doesn't register because quarter, you think of 4, but it's 3 months in a quarter of a year. Okay, so that's what we're going to solve. We know this one is 2, and I want this one month. So I have to take this one to the power 1/3 and minus 1. I'm going to skip a step. That's what I solve. So I'm dividing in the exponents, in the powers, I'm dividing by 3, but not dividing as a denominator. But in the powers, I'm splitting up a quarter into 3 parts to get at the month. So let's put this in our calculator. 1.02 to the 3rd minus 1. What do you get? 1.02 to the power, I'm going to put 3 and then I'm going to invert it, equals minus 1. That is my rate. Want me to do it again? 1.02 to the power, so y to the x, 3, but flip the 3 so that I have all the decimal places recorded in the computer or the calculator, and then equals that, take off the principal, that's the rate. So, that's my rate. So this is equal to you can write it down 0. You do have to show this on your test, okay? 662271. You can put the dots to remind yourself that there's more decimal places. And you can make a note, you're going to store that in 1. Then, all we've done is found the rates that we're going to use throughout. What next? What do we do next? Do I work on the cash inflow or the cash outflow? Yeah, the annuity equation on which annuity though? There's 2 annuities floating here. Do I work on the cash inflow of my contributions or do I work with the cash withdrawals? Right, the withdrawals, because I have that information. So let's get that. So I'm going to take $8,000. I want $8,000 for 30 years after I retire. I'm so picky. So the cash outflows are going to be for 30 years, starting at after you're 60 years old. So for 30 years, starting 1 month after age 60, just to make a note. Now that's fine, right? 1 month after age 60, that's what we like. Our annuity formulas are always begin with a payment 1 period after you want the valuation. 1 period after 60. So, I'm getting used to my Apple Pencil. It's very sensitive when I don't hold it right. Okay, PV 60 years. Or maybe it's better if I write this as, no, I'll write it as 60 years. It's okay, 60 years is going to be $8,000 for, I'm just going to write I, which is fine because I have that rate up there. Or maybe I'll write it as EPR 112. As long as you tell me which one you're using, you don't have to write out the whole number again, just once. If you want to use colors in your test to circle things or square things, that's nice too. Just you have to color scan it. so it retains the color. Okay, how many withdrawals are there? It's going to be 30 years of 12 months, so that's 360 months. So this is 360. Do that again. So you can figure that out, right? You can get the present value. So this is out in the future. I want to know how much I have in my fund. Right. So we need the PV out in the future. So just for you, for the sake, this is in years. Oh, let me write it. 60 years. Okay. This is where I want the PV. So I'm going to accumulate all the monthly payments in here back to time 60. So this person plans to live till 90. Well, us. This is us, supposed to be. Okay, so what do you get? So putting this into the calculator, from left to right, we enter 360. The interest rate, which I have, is this it? No, this is from a different problem. I have to compute this one. I didn't save it. So I have to get the interest rate, which I calculated as 1.02, 3 inverted equals -1. So I have to times that by 100. That's the rate. I'm going to store that. That's the percentage rate per month. So it's less than 1. So I'm going to put that, that's percentage. The PV is what I want. The payments are $8,000 a month. It's a lot of money. And I don't want the future value for that. I'm going to put 0, and I'm going to ask to compute PV. And it comes a negative because I'm with, I put positive payments in there, so I get a negative present value. That's what it's worth. In fact, very good. So we have the same number. Okay, now what do we do with that number? Okay, we're going to store that in 2. I'm going to put it on the sheet. So do not round intermediate calculations. So I'm going to put the answer here as 1,095,000. So this is how much. To be able to achieve that goal of $8,000 a month, you have to have accumulated $1 million. Now remembering pensions, what goes in is what goes out. I have to have that amount in the fund. So this is also equal to the future value of these. Actually, let me put that lower. It's the future value of accumulating these payments that will go here. Okay, so it's all the payments here that I need to know what the size is to get me there. Those are all payments in there, monthly payments. So I want to know C1 because they're all going to be the same. I want the defined contribution. I might be using terms you've heard or not heard before, but that's what it is. That's what we want to find. The first one, because they're all the same, we want the annuity. We want the contribution amount for the annuity that it builds to become $1 million. So I'm going to put this one in store 2. So I'm going to use that obviously. And write the second equation. So contributions. And again, don't hesitate to write your test in Spanish. The TA will understand and I will understand. So cash inflows for now it's going to be between age 25. So for 35 years. So this all should look familiar. Okay, so the numbers are slightly different. I want to get the future value, the payment from going from 25 to 60 years out of it. I know it's tricky to keep it straight. So it's 35 years of contributions. But 30 years of withdrawals. So this could be you. You can accumulate $1 million if the catch is that you need that interest rate, 8% per year. Well, it was actually effectively 0.6 a month, 0.66. It was stated as 8% per year, compounded quarterly. All right. So what do we do next? I wrote down I need the future value, so let's get the future value. What's the future value? It's going to be the annuity at time 0 of making these contributions, but then multiplied or accumulated as a lump sum to now I don't want this to throw you off, but okay, I'm going to do it as months. So what you're going to do is write the annuity formula like you know it, but then that will be a lump sum amount that you can convert to the future value. That's how I taught you to work with future value formulas. That's what the calculator does. I don't want you necessarily to memorize new formulas. It's up to you if you want to write these as separate formulas. But for me, they're just a combination of annuity and basic time value of money. And I need to accumulate this for how many months? Oh, did I do that math? So it's going to be 35 years, or 12 times 35 equals 420 months. So that's 420 months. What's another way that I could write that? Could I also write that like that? If I had the effective annual rate, I can get it, I can compute it. I could also do that if I had it. Yes. So getting this out of the calculator is easier than writing this down. So I'm going to write it first, and then we're going to get it out of the calculator. So those are the same thing, okay, if you had the EAR. Let's do this form of it. So I'm going to write this out. I want the payment, or C1. I can write it as C1, because that's what I did on top. So it's C1 over EPR 112, 1 minus 1 plus EPR 112 for 420 payments times 1 plus EPR 112 420. That's what you write for your test. And then all you have to do is put it in the calculator. In the calculator, you enter just like von Meide wrote. You put 420 into n. You put the recall 1 into your interest. The PV is that amount. You put recall 2 into, I don't know. Yeah, no, I'm not going to put anything in the present value. I'm going to work with the future value, okay? So I'm going to put 0 into future value, present value, and payment is what I want. And then put recall, can you see that? And then put recall 2 oh gee. Okay, put recall 2 into future value. Okay, so I'm not going to use the present value version, but I did have to write it for the formula to express the formula here. But in the calculator, all I have to do is tell that I have the future value. That's the present value. Let me write it in a different color. So this amount is the same as this amount, but I want the future value, which is the green thing. Then you compute payment. And you get the result, 483.90. Questions? So this is virtually the same as the one in the notes at the end of the chapter. Final answer. Or circle it. Well, you're going to write this formula in yellow. You don't have to put that's all you have to write, because this number you have above, you don't have to recopy this number. This one you don't know, you're trying to find it. And that's it. So that's all you have to write. Okay, because you've already expressed this number above. This one you don't have. So, like, these numbers you need here, 420 and 420. Okay, what's next? Okay, so what about 12? There's no solution. And 12, 16, 17, 18, 19. Somebody asked me to do something above. Let me see. 13 and 20. 13. Okay, 13 and 20. 13 and 20. About 13, you have the answer. You have the answer. It's not a good answer, or you get a different answer. All right, so it's 10, 18. We're just at an hour. Okay, we have a couple more hours here. We have time. Okay, let me look at 13. Even though you have the answer. Are you sure it's 13 and not 12? You know how to do 12? Okay. Let's see what's up with 13. No, I don't want to do that. Do that again. Okay. George Hatton just paid his last semi-annual dividend 1 month ago. You expect future semi-annual dividends to grow at a constant rate of 3% per semi-annum. Given the risk of GHI's stock, the effective required expected rate of return is 25.44% per annum. Okay, let's work with this. Okay. So the first step is to identify the timing of the payments, right? So step one, I always write step one and then that's it. But anyway, just to accentuate, you need that. You have to think, you need that in your thinking process. Timing of payments. Is semi-annual. So you have the rates 3%, and I'm going to read that one as effective, even though it's not exactly clear. It'll be easier if I see that as effective than if I have to convert that. So I'll say the growth rate is 3% effective. I agree that it's not clear. So if somebody converted that, that's fine. I would have marked that too. I have to be very careful on the test to be clear. Given the risk of GHI's stock, the effective required expected rate of return is 25. So R, or I, the interest rate, or the required rate of return, it's given as an annual effective rate. So you're given the annual effective rate of 25.44%, but you need the semi-annual effective rate for the problems. So you need to convert that. So you need the semi-annual effective rate, but you're given the effective annual rate. Oh, so 13's okay, Tiana? So the relation between these two is that 2 semi-annual periods make a year. So I solve for the effective semi-annual rate like that. Is everybody else okay with 13? Tiana's pulling out. She says she doesn't need it. Ariette, you still on 13? So we have the rates. I have I have to put in my calculator, but I have the G, that's effective, semi-annual, I'm assuming, and 1.2544, 1.2544 to the half, so I can just put that to the power y to the x 0.5 equals minus 1. It's 12. That worked out nicely. Okay, so we have this. And now the dividend was paid a month ago. Okay, so this is just tricky with the timeline. You got to work with the timeline. You have to make the timeline and adjust for today. So you expect future semi-annual dividends to grow. So okay, the current price is $54 and the dividend paid a month ago is what you want. Okay, so it comes every 6 months. So this is very realistic, right? You're opting in at an interval, not clearly at 6 months of the year. You're buying this, you're looking at purchasing, or prospective investors are looking at purchasing this stock and they're trying to value it at some point in time that's not exactly a 6-month period. So that last dividend, in fact, was a month ago. So anybody buying it today or trading it today wouldn't be considering that dividend because it's past. We only care about future cash flows, the present value of future cash flows. So on a timeline, we're here, and this is a month ago. But 1, 2. So I'm going to use larger tick marks to denote the years and smaller tick marks for the months. So 1, 2, 3, 4, 5, 6. Okay. So if the dividend was here, then in 1, 2, 3, so 1, 2, 3, 4, 5, 6 here will be the next one. So I'm going to mark them as 1 month, 2 months. So the next one will occur okay? Now the relationship between these is what's important. That's for the pattern. We are told that the one a month ago, no, the one, what are we told? Just the price today. So we're told the price here of 54.06 So how are you going to match these things up? And ultimately what I want is I want to find this. That's what the question is about. So because of the formulas, the way the formulas work, all I'm going to be able to get out of this immediately is, let me shrink this a bit just to make my point. Sorry for my uneven timeline, but so this is going to be a payment here, right? And then it's going to continue every 6 months. 1, 2, 3, 4, 5, and then 6. That's going to be 11 months. All right, so if you zoom in, where the large tick marks are, so it's 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. That's all I can work with. If I zoom this way, you're not going to see even the monthly tick marks. Trying to shrink it. It's not letting me shrink. There we go. Having some difficulties here. Okay, so the point is that my formula I want to use the growing formula, the perpetuity, that looks like this. 1, 2, 3, that they're all related by C1, where they're all related by C1 and G. So where do I see that on my timeline? How do you visualize that on the other timeline? Where do I have to be? Where can I work from? I can only work from one period before the first payment. That's the only way I can apply the formula. So where does it have to be applied? Where can I apply the growing perpetuity formula? Tell me the position on the timeline. Not in 0. It can only be one period before. For our problem, one period before is one semi-annual period before the payment. So where is it? Somebody else tell me. Where can we find the value? Where can we apply the formula? Where's the only place on this timeline we can apply the formula? It's one of the bold marks I made in my timeline above. One of the darker marks I made. Nobody? Now, even with the formula, I appreciate you guys aren't just writing the answer, just staring at the solutions. But I really want an answer. The C1 to use is the one at 5 because it's the next payment. So, given that, where is the value? Where can I apply the growing perpetuity formula? Where would the price be? Where would I price it? Which point in time? I'm going to use I want to include this, this, and all the ones forever into the future. Remember, this goes forever because a corporation can exist forever. But theoretically, and to make a simplification, we assume that those dividends grow forever at a set rate. All right, so you guys are not getting it. It only can be here. One period before the first payment. That's why I have to specify it's the 1 month before now. So that's where the value is going to be. So I'm going to apply the formula. I'm going to apply the formula right here. How, let me erase all of this other stuff I have down here. That didn't work. That did not work. What I'm going to do is going to cut it out. I'm going to cut this out. This is all I need, right? Okay, and the growth rate was 3%. And over here is where I can have the value because the formula fits perfectly. So that the first payment is in one semi-annual period from now, and then I divide by EPR 1/2 minus G. That's it. It's a very simple formula. I just need to know where to fit it. It's a very simple formula. You just need to know where it fits. You have to identify where it fits. It fits there. So what do I have? Do I have any of this information? So I'm just trying to make this simple. So 1 means one semi-annual period from now. I do have the price at time 0. I don't want to bold that because I want to differentiate that from from the timing of payments or the payments. Okay, so the first one, I don't know exactly what it is, but I know everything is related by this. But this is the price at time 0. So what's the relationship between the price at time 0 and what I need here? This is just a lump sum. This represents all those future cash flows. It's already done all the math. It's one number that it represents the future. So I don't actually, it's in there. It's all captured inside of there in a formula. Or it's been all accumulated in there to come up with that price. So with that lump sum, this is a basic time value of money problem to convert the price at 0 to the price at -1. All I do is I take the price at 0 and divide by the monthly rate. We don't have the monthly rate, but we can get it. I have to get used to making straight lines. Okay. So just 1 month back will give me this. This is really at 5 months, or, you know, in terms of months. So I'm going from describing this to you to now I'm describing it in 2 different ways, but this is how you do it. So this is going to be EPR. Because the payments are semi-annual, I have to use this, and the growth is semi-annual. Are you following? You're very quiet. After this test, I'm going to start asking questions. Make sure you're actually there or actually benefiting. Okay. All right, so I did 2 different expressions. I say this is a direct application of the formula. But now I have to make the adjustment because I'm off time. I only know about PV0. So this is what I would call like my step 2, according to my summary notes on valuation. So that would be step 2, the direct application of the formula, and then you make your adjustments. So step 3 would be to make the adjustments. So I don't know, the yellow things are unknown. But again, they're all related. They're all related by this formula here. So let's put in what we have. We still need to get this. I'll use green to denote what we need. So we need that, which we can get. We can calculate that. We need the equivalent monthly rate, effective monthly rate. And what we're solving for is going to be, what are we solving for? We have this. We have, I'm going to use a different color. So we have this, we have this, we have this, we can get this. So what we're solving for is that. The cash flow at the 5-month period. Yeah, if you can use the upper one, that's great, but we have to find this first, right? So that's how we find it. So let's plug in everything we have. Oh, this is when I don't like when things get separated, and I don't know why. Take screenshots to help so you don't feel I'm going too fast. You can have the screen shut. So I'm going to first get the thing I circled in green or squared off in green. I'm going to convert to do that one more time. So I'll do it long way. So I need the monthly rate effective, and I have, because I computed it, the effective semi-annual rate. So now what's the relationship? Which one is smaller? Months are smaller. There's 12 months, or sorry, 6 months in a half of a year. So I can solve for what I'm looking for, the monthly rate, the equivalent effective monthly rate. Okay, I'm going to finish this and we're going to take a break. So this is easy because it was 12, if you remember, that's above. And then 1/6, so you're going to divide a semi-annual period into its month parts in the exponents and get this number. Oops. So how do I do that? I take 1.12 to the power 6, and you use 1 over x to flip it, and then minus 1. So that is the monthly rate. I can store that in 1 as a decimal. So I'm going to put it on my document that this is equal to 0.0190673 and say store 1 to remind myself I stored it as a decimal and not lose any of the decimal places. And make it a little smaller. So I got that. So I got everything now, right? Let's write out, let's put the numbers in there. So 5406 discounted 1 period back. I'm still going to write this out because I don't want to transcribe the decimal wrong. And then you just have to plug all that in. I can actually put G because that's not so long a number. Well, either is, I can put them both, they're small numbers. Okay. You see how you can do this now? So you're going to find the equivalent amount 1 period back and then multiply it by the denominator. Oh, you can't see that. And solve for, so you see you still need to do algebra. The calculator is only used when precisely the formula is applied, but all these adjustments are necessary for this problem. So you don't have to show me all the, I mean, I see everything there, just make sure you punch it in properly. So I'm going to simplify this to 9%. And so what I'm going to do is go to my calculator, add 1 to the rate, then put it in the denominator and multiply it by 54.06. So I'm going to add 1 to this rate, and then I'm going to put it in the denominator, and I'm going to multiply it by 5406. And then I'm going to multiply it by 9%. And I get this number. Okay, I did a little bit different. Let me go back for a second, just so I can make it look like the other. I'll do it like I did it exactly in the notes. So what I did was I said, I'm gonna say or, because what we really want is the cash flow at minus 1 month, right? And that's gonna be, what's the relationship between that and the one at 5 months? We know what that is because they're related by a growth rate. Oops, I did it again. So I'm going to go one more step. I'm going to add in one more thing so I can get directly to what I'm looking for. And green is what I'm looking for. What I want is this. And I know this, right? So I'm going to punch that in. I'm going to plug that in to here. And then I'm going to solve it. And that's going to be exactly how I have it in the note. So one more step. Or should I just erase that? No, I'll write it again. So yes, you can do it however you want. Just be clear and clean it, neat and tidy about it. You see that? So finally, all I want is this. So do the algebra and you can get it. So you should get $4.64. Are you getting this? That's right. The fifth month is equal to the 6 months ago times 1 plus g. Correct. Because the dividends are growing at 3%. The dividends are related. Every 6 months. So if you count every 6 months, 1, 2, 3, 4, 5, 6. You see? So that's the first one. Then the next one grows, and the next one grows more. So this is equal to the dividend at 1 month ago times 1 plus g. And then this one is equal to the dividend 1 month ago times 1 plus g squared. Now I'm writing dividend and I'm writing C1. They're the same thing. C subscript. So you should be able to make these adjustments. You need to practice. It's like div. I'm going to write div. Okay, so you have to try and maneuver your variables to fit, maneuver the problem to fit the formula, and then make adjustments. So it fits like that. It fits that I work from here and it's with C1, the one that's coming 6 periods from now, 6 months from now, or 1/2 a year from now, and I use the growing annuity formula. This is in the denominator, but the first one is the 1 month ago times 1 plus g. So I think you guys get the formula. I think you have trouble with the cash flows. So work with the timeline. This is the point of having the timeline, drawing it and working with it. Let's take 5 minutes. Let's take a 5-minute break. Get some water, get a snack. Use the restroom, and we'll do number 20. Sorry for the long break. I had to answer some questions from the department or from the faculty. Okay, we're on to number 20. Sorry for the long break. I had to... Whoops, echo. You see my delay. 20. That's it? Just 20? No other questions? So this is the Gordon model, dividend growth model. That's how we deal with this. The dividend growth model. Dividends grow, they change. They can go up, they can go down. And if they're related by a constant growth rate, then we can use our formula, our simplifications to solve for them. Solve problems around them. This is too big. There. All right. So Winkler's first quarterly dividends. So dividends are quarterly, so that's our step one. It's expected to be 3 years from today with an amount of $1.20 per share. Each subsequent quarterly dividend is expected to grow at 2.5. After 7 years, they will grow by 2%. The effective annual rate is given as the required rate of return. All right, so we have I see you want me to do 15, but the answer is there. I mean, I can step through it. So I don't have the timelines, but I'll present it to you here. So they're quarterly dividends. I need one more. Let me do that again. So today is now 1, 2, 3 years from today, and this is 7. So I've drawn it in years with the green, but then payments are quarterly. So I'll just expand it if I need to. So what's going to happen is, first one begins here. So this is like our dividend at 3 years, and you can see that as how many quarters. I'll just call it C at 3 years for now. It's going to be $1.20, and then quarterly dividends, so there'll be 1, 2, 3, and 4. Let me do that again. 1, 2, 3, and 4. They grow by 2% each quarter. Sorry, 2.5%. So in here all the way to 7 years, these are going to be growing at 2.5, but then it drops to grow at, I'm going to use a different color. So after that, it grows quarterly at 2%. So it changes. Okay? So let's read that again. So the first one is $1.20 3 years from today, and each one after that is growing by 2.5% until the 7th year. After that, they grow by 2% per quarter. Okay, so that's the drawing. What is the price today? So we would focus on this stuff over here. Because so looking at what I've been given, where could I find the value, the price? I'm going to do it differently than I did it here. But you'll get the same answer. So if I treat this like an annuity, with growth, because there's a set number of payments, and counting them, it's 1, 2, 3, 4, 5, 6. Oh, the first one is here, right? So there's 1, 2, depends how you want to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So basically, this is the same thing as I explained to you. Between 2 points, how many payments are there? You could call this 3 years or 12 quarters. And you can call this 7 years or 28 quarters. And then all inclusive, the number of payments would be 28 minus 12 plus 1, right? Or you can just count them. So you have to remember that we learned that, how we count payments. 17. Got it so far? So that's 17, and then this is a perpetuity beyond. Oh. Got it? So what does that accomplish? So what I think what I'm going to do is just lay this out, and then I'll just look at the formulas I wrote in the solution set. So my question is, if I use the annuity formula with growth, where would the price be? Where would the present value be? Which point on the timeline? If I use 17 payments, anyone? But if I applied the growing annuity formula for the first set of amounts for this, where would the price be, or the value of that annuity? I know what I want. I want the price today, but if I was so step one, we have to get the quarterly effective rate. Step two is to apply the formulas where they fit on the timeline. So if I want these payments in an annuity, where would it be priced? The answer is one period before the first payment. The first payment is 120, so one period before would be here. The 11th quarter. You have to go with periods of timing of payments to work with this. 1 period before. So since that annuity will go in here, can we also add the rest of it, the perpetuity? So let's do that. That turns out to be I'm just going to write EPR 1/4 for now. So this is the annuity. Oh, sorry, it's a growing annuity. Let me fix that. Right, growth on the top, the discount rate on the bottom, and this is all to how many payments? We counted 17. So that's the annuity piece. And then what else do we have? Maybe we'll do this separate. So that then we have this growing perpetuity that starts growing after year 7. So let's separate that. So where would that be? So this is, let me just recap. So this is our C1 here. That's the first one. So that's why I have to go 1 period back to value it. The first one for the perpetuity is the tricky part. You have to figure out what the first one is going to be. It's the first cash flow, and it's the first cash flow for the annuity. What's the first cash flow going to be here for this perpetuity? It's going to be here. What is it going to be? Anyone with me? I've got about 10 more minutes to wrap this up. What would that first cash flow be? How would we figure that out? At every point here, starting after year 3, growth kicks in. Growth, 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 all the way for how many periods of growth? So this is a perfect example of distinguishing between payments and growth. Because I'm starting here and the growth begins here, how many periods of growth are there? Between 3 years and 7 years. Excellent. Right, okay, so there are, until here, let me make a note. Between year 3 and year 7, or in other words, 12th quarter and 28th quarter, there are 28 minus 12 periods of growth. Intervals, right? I'll call them intervals of growth. So this is the difference between payments and intervals. So you have all the tools, you just have to realize you have them. You do have all the tools, you have all the formulas you need and all the tips you need. So that's a total of 16 intervals of growth. Then the growth rate changes, but it's another interval of growth of 2%. So that first cash flow for the perpetuity will be $1.20 times 1.025 for 16 periods of growth times 1.02 for 1 period. So let me square this off. So this is the first cash flow for that part, and this amount is the first cash flow for the second part. All right, now what? Now it's just, so we've applied the formula. We're going to apply the formulas. Here's going to be in the first part, I already wrote it. I described the annuity. In the second part, I have a perpetuity where that's the first cash flow here. So the perpetuity actually, I'm not going to write that again. I don't want you to think it's something different. This is just the annuity with growth part. And then the perpetuity with growth, I'm going to write just a side. And the price, if I do it this way, it's going to be at 7 years or 28 quarters. And the growing perpetuity is the quarterly rate minus the G. Oh, well, I'll just write the G in. So I have this floating at 28 years. So this is the present value of future cash flows beyond 28 quarters or 7 years. Did I say 28 years? 28 quarters or 7 years. And this is the present value at 11. So it's like I have to bring them together. So I have to do some discounting of this amount and also of this one if I want to bring them back to time 0. So what I'm going to do, just keep the color drawing up and I will show you, I will grab the solutions. Let's see if I can do that. See if I can get the solutions easy enough. I just want the last one, right? I'm going to pull this out. And take it with me. All right, let's see. First, we get the rate. So that's always the first step. Even though I kind of jumped forward, you should be able to get the effective quarterly rate, which is step 1. I'm going to move this up. Find the timing of payments, compute the quarterly rate. There it is. So from here forward, I'll write APR 1 quarter. Then I do this is the presentation of what I'm going to do, the present value of the growing annuity. So we did that, but I need to get the present value. We still have to figure this out. We still have to do this because we only have the present value at 11. And then we need the present value of the growing perpetuity, and we have it at 28. But we have this part of it. So I refer to them as A and B. But you see now where the formula comes from. So this is the annuity here, and it has to be discounted 11 quarters. And this is the perpetuity, the first cash flow, and discounted 28 quarters. And that's it. So really the question ends there. I did it a different way, but I'm going to circle. It ends here. That's basically it. You could have done it differently where you let you go up to 27 And then you let the, you do it not to 28, to 20, one period before the growth kicks in. So then that's the only difference there. Otherwise it's the same thing. Well, I did everything one period before, right? Because this only goes to 16. So I let that one cash flow go with the second amount, set amounts for the perpetuity. Anyway, if you get it this way, don't worry about the other way. Okay? You'll get it when you're not nervous about the test. You'll see it's the same thing. But you get all of this, right? The first one. This is the 11. This is the 28. That's it. Those were the formulas that we computed on the top. I just substituted. So in the test, you don't have to write all this. You can just put EPR 1/4. So with that, there's 17 people left, 18 people watching. Well, I think one of those is me. So only half the class, about half the class is here. Hopefully everybody will watch the video. And all the other videos, there's tons of videos. You can, if you have time, you can go through all the other videos in FINA. I do similar problems, and you have all the questions that I'm solving in those problems. Do you have any more questions? No more questions? It's 11:47. The test is at 9 a.m. If you have questions, you can email me to see if I can resolve any of them. But you have all these materials. If you need to meet with me later, I can meet with you on YouTube after about 6 or 7 o'clock. After about 6. So if you really need me, we can meet after 6 on YouTube. Okay, so let me know. Text me or email me. Otherwise, I'm going to say have a good day and a good night, and I'll be in touch tomorrow. The test is between 9 a.m. and 3 p.m. It's on the syllabus, and I will email it to you, and then you have to email it to me back after 3 p.m. I will not accept any test. It has to be before 3 p.m. It should take you no longer than an hour and a half, but I know some people will probably want to spend more time than that, which is fine. I just gave a 6-hour block because it is a Saturday and people have things to do. So I imagine, you can find an hour and a half in there somewhere. You shouldn't be communicating with each other during those 6 hours. Okay, you should have your documents assembled and ready to work independently. I want you to send the email back to me with the test in PDF of the solved problems And I want it as one document, please, one document. I didn't make the test yet, but the test should take you an hour and a half. I didn't make it yet. I don't like to influence my teaching by the test. So I make the test after the lectures. But you should be able to finish it in an hour and a half if you understand this material. But in the case that you need more time, you've got more time, so no worries there. It's only worth 10% if that's any consolation, but after this test, I'm going to assume that you have this knowledge. So if you don't do well, I suggest seek extra help or let me know. I do have a TA, but I think it's better that I tutor you until I'm of no help to you. As long as I'm available, and I usually am, I can help you. If you really need remedial help, I can put you with work with the TA, but we'll see after this test. I think the first test is, did I say 20? I think it was 10. I gotta check. You're checking probably, because I keep saying that. I thought I just checked it. The 10% is the 10% is the connect problems. I did make it 20. Yeah, I keep on saying 10. I don't mind making it 10 and spreading the 25 over the next two. What I'll do is, if you do well, you get 20. If you don't do well, you get 10. I'll make that concession because I've been confusing you by saying 10. Usually I make the first test worth less. We do have the date for the final exam, but I'll talk about it after this test. I think it's, I can't remember. I think it's December 17. I have to check. It was tentative, so I'll let you know when it's confirmed. So the final test is 30%, and it will be in Connect, and it will be with the camera. So even though you have liberty to work with more time during the semester, use that time wisely, okay? Remembering that the final is worth 30% and it will be with the camera in Connect. Okay, any more questions? Wow, we're just eating up time. Well, thanks for sticking around. Let me know if you need anything after 6 o'clock. I said I can meet with you on YouTube for office hours. If you know, if that's necessary. If I can explain a concept in email, we'll do that. So no cheating. It's not going to be hard for me to tell if you're cheating. It's pretty easy. Proving it might be another thing, but I do mention in the prontuario, if I see the same mistakes and they're clearly, uncontestably copied, you will lose double the marks. And I can't even talk about taking further integrity, actions against, because, that's academic integrity. And we have to work as hard as we can to evaluate students on their independent work. Group work is important, but obviously not for quantitative. And you have all these tools, so you shouldn't be worried. You have all these tools at your disposal. Work with what you've got. Have a good day. Good day. In every question, you have to have the formula. I don't know what you mean, la tabla. You have to have the formula and you have to have the answer, unless I say show your work. If you have to show your work, you have to do all the steps. You have to show me all the steps of the algebra. But if I don't say that, you just timeline. Timelines are necessary for questions like we just did, where you have to show. So timelines are important if you want part marks. Maybe you got the wrong answer, but if you write a timeline that's consistent with your exercises and your timeline is wrong, I'll give you part marks after taking off some marks, some points for interpretation, failure of interpreting the problem properly. But if I can follow your timeline, if the grader can see what you were intending to do, you have some chance of getting the right answer. Obviously, for bonds, you don't have to put a timeline, but for these differential growth model that we just did, for mixed cash flows, make the timeline. Or there's no way I can give you extra points. The stream was not buffering at all. It's very good. I have both Wi-Fi on and Ethernet, so if one fails, the other one works. Now you guys can study together. Please, I encourage you, try and make small groups. You guys can study at distance, or I don't know how you guys do it, but you guys figure things out. Or in small groups if you feel that it's safe in an open environment, in a aired patio or something. You can get together and work together. If you're working on your own and you feel you need additional help, let me know and I can meet with you. I like to post the YouTube videos because everyone can benefit. It's a matter of scaling up the benefit, to everybody, if I'm going to go through the trouble of sitting down and solving problems online. Okay, good afternoon. Bye-bye.